hot mic from somebody. Who is that? Steven, you got a hot mic. All right. Awesome. Thank you. Okay, hang on. There we go. It should be live. That's it. So I am posting the posting the link. And then let's see, Devin, are you on? Are you on right now? Would would you mind grabbing that link and sticking it in the class schedule? Yeah, the one that I just dropped in the chat. What's that? Is that latency a YouTube latency that I was just hearing there, or is that a Discord latency? So just enough latency there to make a little echo. Okay, all right. Um, all right, so we're going. So first thing first, let me give you just kind of a quick update on where I'm at. Now, the good news is we still have, the now no longer aptly named Skater Chick book, the Heads Up Design Patterns book to guide, and so that's good. I mean, there's stuff to do independent of our discussions in class. So that's, you know what I mean. There's sort of meaningful stuff. I did notice that there was a posted question. I can't remember. I guess Tobias said relative to chapter 5. Did that ever get? I didn't see a response to Tobias's question on the chat about uh, the looking for chapter 5 for the golf assignment, that the chapter isn't completely on O'Reilly.com. Is anybody else having that problem with chapter 5? You would have to have tried to go look to do chapter 5, probably, and that may be a slowdown for at least some of you, but okay. So Tobias, do you want to just maybe you can maybe debug, if somebody wouldn't mind jumping on, and see if you can figure out, Tobias, you know, what's going on, man, whether that's just pilot error or whether that's some, login thing. I don't even know. Sometimes I know with the UVU materials that if you haven't logged in a while, it'll sort of like kind of quasi give you access, and then at certain points it won't, and it's not always crystal clear why it's denying you. And then you log in and everything is, I don't, that's just a pure guess on my part. So, um, also by way of catch up, I want to tell you about my own kind of health and post surgery and where I'm at. Braden had said there are discussions about a midterm. Can we get a date on that? No, not right now. Eventually, yes. My promise to you is that, and for those of you that have had me in any other classes, especially, it would be like 305G, and Devin and Tim can certainly, you know, kind of provide the alternate, witness to this idea that when I get into an unanticipated interruption on my side, I try to be super accommodating in general when there are disruptions on your side, when there's just things that happen, even if there are like, stiff deadlines and stuff happens in your life, you know what I mean? Loved one has a baby, maybe you have a baby, whatever. Um, and I'm always super accommodating, when that happens. When something like that happens to me, it sort of flows out and kind of disrupts everything. But again, my approach and philosophy is to be, accommodating for you guys, you know. So, like with all these things, you already know what the doing the chapters is. We know what that is. Get into something like the midterm, we'll figure out when it is, and whatever it is, whenever it is, we'll make it fair. That's kind of just my promise. Whatever we do, we're going to make it fair, and we're a small enough class that we're just willing to work with you. Okay, is that cool? Is that, I mean, that's kind of like as fair as you can literally be, I think. And so my kind of philosophy for life is, step number one, figure out what the right thing to do is. Step number two, this is my algorithm. Step number two, do that, you know, which will move you to a new state. It's now your state of the world around you, in the state of having done the last right thing to do. Now, this puts you in a new state. From this state now, figure out what the right thing to do is. And you just literally just rinse and repeat. So, and then you just have to be guided by kind of, your own moral principles, right? And then, intro 305G. But everybody cool with that? Everybody good? Um, with that as an approach? Okay, Devin, thank you for dropping that link into the class schedule. So let me tell you, Blake represents. He speaks for all of us. Blake represents apparently 6, 12, 14, no, 13. Yeah, Blake represents the entire class. Thank you, Blake. Somebody has to speak for the class. Let me tell you about my cool adventure. Let me take off my cool UVU swag. So 2 weeks ago was the surgery, spinal surgery, L4, L5 fusion, the spinal frontier. And so did the surgery, things went, I don't know, right? I mean, things went well, I think. And then, but I have had funky complications where I've popped out the other side with sciatic nerve pain in the good leg. So I had this, I had like the good leg and the bad leg. The bad leg pops out doing great, and the good leg pops out like just super pissed. And then it was like, okay, how do we get on top of that? And so I was on a medication for a week, that was designed around that kind of nerve pain, pretty popular. And it had the effect on me of mitigating the sciatic pain about 90%, but the remaining 10% was pretty bad. So I'd still have to supplement, with other, kinds of narcotics. And it had a tendency to turn me into like a rando narcoleptic, where I would just randomly fall asleep, you know? Like I could be like I was dropping a polo to my sister, in the middle of all that, in the middle of the polo, I just stop for a second and just like, just like close my eyes and fall asleep, just like rando. And there were a number of I actually woke up at one point in the middle of the night with my laptop on my lap, on my recliner, on my chair, just sitting there with my hands on the keyboard, sound asleep, and hardwood, and all it took was a tip, or a startle, and that whole thing would have just been like torqued angle with the lid, with the laptop lid open. Anyway, so I mean, it was just, so there's no coming back to work in that state, and I literally took the last of that med about 30 hours ago. So like early yesterday morning was the last of that, and then literally just last night started a different med for the nerve pain, and this one appears to be the Majike. So that is why I'm here, having class and talking and updating you and getting ready to actually hit a few slides and talk about design. Um, so crazy crap, man. And so, but it's not like normal. I don't know how often this kind of thing happens, but it's definitely side effect land. You know what I mean? Where you don't. It was not supposed to pop out and have like this is the thing. Not supposed to be the thing. So that has been a real disruption because if it was just the back pain from the surgery, from the surgical site, which was another, what did I figure? The surgical site, it was 26 staples. Staples came out yesterday. It's probably about 6 inches. Yeah, about that's about the length, from here to here. That's about the length of up my back, and then staples. Ching, 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 ching. So that's as close to a demo of the staples and or the back as I'm going to give here today. So, which you should all be grateful for. Okay, so that's what's been going on. And originally, I just was like, yeah, I'll be on pain meds for like a week. And I had no idea I'd be fighting the psychotic. The sciatic pain is psychotic. It's like this. I don't even know what it is exactly. Thinking about, there's that one scene at the end of episode 6, Star Wars, where the Emperor's like doing the thing to Luke, and it's like, it's lighting up his fillings, and right, and he's like, that's basically sciatic pain, I think, only localized in my case to my back and one leg, and just there's no play, man. There's just no play, and it's brutal. So that's been a bit of a weird distraction for me and has definitely slowed down my recovery and getting back. But as you can see, I am in my office. I have my brace on. Okay, I do have my back brace on while I'm sitting here. So there's that. So you guys, any questions at all? I mean, we're friends and associates and just anything nagging that you know again, voice chat, fine. Text chat, fine. But is there anything nagging at you about that? And this is my hospital. This is my Intermountain Health Care. This is my little jug from the hospital. It's so handy, man. Braden, yep, that one we just go offline. We DM on that one. So Braden, we can probably talk a little later about that. Again, it's all about me coming online and literally until today. Well, yesterday I did do a lecture for 305G audio only, lectured from the recliner. Um, but uh, and that was because I had gotten away from that previous medication, which was turning me into a narcoleptic. So once I got past the narcolepsy, I was much better shape. So this is better. It hurts. Just still, I mean, it hurts pretty good, but it's not that. There's still the sciatic is a different thing. Anyway, any other so Braden, we'll talk. We'll go. Okay, thank you, Braden. We'll hit it. And by the way, the real gotcha for me was that the morning after the surgery, when I got up and got on my walker, which is at the top of my stairs, got on the walker, and then the right leg, which used to be the good leg, which is now the bad leg, and went to just go take a step, and it just like steps and then just buckles. Nothing, man, nothing on the right side, like no strength, almost like you're just paralyzed, and everything just starts going down, and I'm just like joint grab the walker. So that's how bad it was. That was my first indication. So let me see. Yeah, Blake, I'm glad to be back together too. Brayden, when good legs go bad. That is a lame movie. It's too early to start the dad jokes though, Brayden. Um, by the way, has anybody been scouting the guy that we brought the his videos that are about um, the head first design patterns? Can't remember what our bro's name is, but is anybody just curious if anybody's been like watching those or following those as a way of reinforcing the study of the patterns and what your experience has been with that guy. So Sam, all the links, if you go to the go to Canvas and may have to log in here, but hang on a second. I'll show you. Yeah, it's going to make me log in. I think we talked about it. Come on, man. Like just before I went off and went under the knife. Sorry, I'm doing the duo dance of authentication here. Obviously have not been logged in, and then I'll throw it on the big screen. So just to reinforce who this guy is, I thought well, and the other possibility is that I actually didn't talk about it. That's absolutely possible. Kind of given everything. Let's blow it up, and what I did was optional. There we go. Christopher O'Cravy. Um, so what I did for every Goff assignment, and they should be, they're spread out here. They're not all linked yet because that was Tim was going to be rolling those assignments out. And do we have 5? Tim, I think Tim was working on 5, which is due coming up actually. And then 4 was, oh, it's up there. It's sorry. Not for me. I don't see a link on, there's no link on 5 and 6. You want to maybe ping him offline, Devin? Oh, okay. Well, and maybe Devin, if you wouldn't mind, I mean, all we do here is just highlight that the same way we did these others. Awesome. Because what I'm trying to do is I'm trying to make this calendar be like a handy resource for all the crap we're doing, right? Anyway, for all of these, here comes Christopher O'Cravy, and I just put a link, like there's the first one, strategy pattern, and let's skip ads. There he is. And I don't think you can probably hear that on YouTube, but not on Discord. And then he does his, that one's 35 minutes. And he just walks through all of the patterns from specifically, where is it? There we go. He's got the Skater Chick book, right? That's it. That's all that is, Sam. And I dropped those in every time, we'd hit a pattern, like there's the observer pattern, and I would just drop in a link to Chris's or Christopher's, I don't know what he goes by, to his resources. Cool. Just to help, just to, you don't have to watch them. I would, but I was curious for those that have had a chance, what you got out of it, if it seemed valuable, you know. That cool, Sam? Everybody got it? So just a resource to help, to help get another perspective on those patterns. Yeah, you bet. Yeah, yeah. No, I got that. And if you can somehow build it in, to your preparation, like as you're doing the homework, you just build that in where you're sort of getting more as you go. That's not a bad strategy if you can pull it off. You know what I mean? Um, it's more of an investment in your own education, as in a sense, rather than if the professor doesn't give me a point, I'm not going to do it. I'm not trying to pick on Sam because, yeah, I appreciate the honest dialogue, right? I really do. Okay, here's what I wanted to do. Any other questions about anything? Thank you, Devin. I'm going to do. over here, I'll just do a refresh and confirm that Goff 2, 3, 4, 5. And then can you go back and change the colors so that they match the other colors, Devin? See that? So I do see the link, but on the schedule, you know what I'm saying? So it matches the same colors as it matches the purple. Okay. Cool, Devin. I don't know if you, yep. Okay. I see the text now. Okay. Here's what I wanted to do. I wanted to just, I really didn't know going in like how much energy or strength I was going to have to just do this today. You know what I mean? And we'll get through it. But something that I wanted to talk about. We talked about managing ignorance. We talked about gestalt, and I'm just confirming. Yeah. We did that gestalt where we did sort of an intro to design, kinds of stuff. And what I want to do is, let me see something. Is this what I want to do? Yeah, no, you know what I want to do? I want to come back to, oh, there we go. Maybe a little UML introduction and why we care. Okay. Let me do that. I want to do that because we got to get to UML fairly soon anyway. And I think this is the right ticket. Come on. Okay, I'm gonna kind of roll through this. We'll see how this kind of goes, but this is the punchline here on UML. Like, why do we talk about UML? That's really what I want to kind of hit on right now. Okay, there we go. Here's the thing. The reason that we do models of anything is because the human ability to handle complexity has natural limits, right? If you say to somebody, oh no, when they finish this skyscraper in downtown Orem, I don't even know where downtown Orem is. Is there a downtown Orem? I don't know. But if somebody said, yeah, we're going to have this skyscraper in downtown Orem, there'd be this moment where you'd be like, well, what does that do to the view, right? Is that going to trash people's view of the mountain, or is it going to look consistent with the skyline, or you know what I mean? And what you would typically do in a situation like that, what historically architects would do, is they would build models out of balsa wood, and balsa wood is really really light. It floats like really well. It's not lighter than air, but it's, the kind of, if you want to build a model airplane, that's balsa wood. It's very, very soft and it's really, really light. Okay. So it's crazy easy to work with. And they would literally build like a scale model. This is before computer visualization, right? They'd build a scale model of the skyscraper that's going to go in, like, with detail all the way up. Then they'd build a model of the entire, sort of downtown. Then people, because it's always very difficult to visualize, right? Then people could walk around the model and look at it from different angles, right? Again, this predates computer modeling, right? So Tobias, the set of slides I'm using right now, the truth. You can't handle the truth. These slides, I don't think that I have a version of these slides up on Canvas, but I can try to get those up there. Tobias, because I can do that real quick just by saving it out, uh, and then just saving it out and uploading it. What say you, Tobias? I can save it as a PowerPoint show file, or I can, make it a PDF and push it up. Okay, and so you've got your own, and you can, yeah, yeah, yeah. No, totally fair. In fact, I looked as I got to it. I looked and was like, uh, noticed that there wasn't all the other stuff. So let me do that really quickly, and I will have those up. Let me see. And by the way, I'm sure that some of I don't know if the titles are going to be right. This is currently number 4, but I think it might change. This thing's only like 9 slides, and then I'm going to just save it as a PowerPoint show, which is the normal approach that I do. Okay, I'm going to just quit that and go back to that. And then, Tobias, I'm dropping it up right now on the under files. And this is going to be lecture slides. Yeah, okay. Okay, Tobias, those are up now. So grab that. Holler K if that's not there, or if there's some problem. They're just called 4 UML introduction. All right, thanks for the heads up on that. Okay, so you're welcome. So yeah, what I'm getting at is that you do modeling all the time. Now we do it in computers. We do modeling of systems. We do mock-ups of interface. We do 3D visualization of spaces. My daughter Aubrey has a interior design firm called Autumn Rose Interiors, and there are a bunch of. She does a ton of remote design where the space is like specked out in a certain format, and she can bring it into software that she's got, and then basically just mix and match and drop things in. So it's 3D modeling, and then you can move around the room again, and above, below, and feel a little bit more like feel the room without having to physically get into the space to do it. And it's just modeling. That's all it is. Because we have to abstract out what's going on. We can't handle everything, right? So we have to abstract. So that's really the only reason we do modeling is because there is complexity, and because the human mind has limits on the complexity that it can handle, right? So um, yeah, so that's the whole idea. Now the one thing about models is that they typically give us a view of one aspect of the system, but they don't give us all aspects of the system. You need all models to represent all aspects of the system. And is there such a thing as sort of a universal, unified model and in any field? And the answer is kind of no. I think it's pretty much no. Um, and I used to, yeah, it's only a model. Thanks, Braden. I used to build homes, right, with my dad, and um, you get on a construction site, and I would do layout, we would do framing, and you get on the construction site, and you had blueprints. I mean, literally the blueprints, and you you ignore 80% of it that we didn't care about as framers. Get to the framing page. Some skipping past like plumbing, electrical, all the rest of the other crap. Well, I don't care about that stuff. It's a model of a different part of the system, right? So, um, and so modeling can be at any level above that, right? It can be the 10,000-foot view. It can be, in fact, typically blueprints have on the near the front a picture of just like the building, what the building is going to look like, just to kind of set some expectation for the builder, right, of what it is they're heading toward. It can be really high level, like a sketch, and it can be really low level, like the detailed electrical plan or the exact dimensions of where walls are going to be and stuff like that. Okay. And so here we have a definition, and I don't have a citation. I don't remember exactly where this definition came from. A model is an abstraction of a system. Okay, it's an abstraction. It is not the system itself, it's a representation of the system, specifying the modeled system from a certain viewpoint and at a certain level of abstraction. So, relative to like exam question, understanding what's a model, this is your canonical definition right here. And right, if you think about it, it's an abstraction. It's an abstraction from a certain viewpoint at a certain level of abstraction. That's it. Now we're going to make our way to UML, okay, obviously. So when you're a software engineer, you've got to be able to create models of complex systems that you're going to then go build. How do you do that? How do you model systems, right, that you need to then build? The ultimate definition of the system is the code, because it does what the code is. The code is a precise specification of what the system is that you built. Okay. But how do you capture and embody the mental model so that a team of 100 people can work on stuff? If it's just you, Ted in the shed, fine. Maybe you got the whole thing in your head, right? Ted in the shed with the whole spec in his head. But when you're 100 people, right? Or maybe 200 people, maybe more, and maybe you're spread across the world, you have got to have a way of specifying and articulating what the chunks are that you're building. It could be really highly structured or it could be very, very loosely structured, but you have to have an ability to communicate. And the bigger the organization, the more you just have to have. And the smaller, frankly, the least you have to, the less you have to have. Okay. Um, and so the engineers on the product dev team have a different perspective of the system, right? There's the customer, the analyst, the architect, etc. You have different, and you think of, remember the orders of ignorance. The reason that this is important is to understand that the tester should be asking different questions from what the architect should be asking. And those are both different questions than what the customer should be asking. They all operate at a different level of abstraction. Okay, that makes sense. And every one of those perspectives requires some different way of modeling it. Okay. How are we doing? I'm trying to gauge the time on the clock versus what time my back says it is, because my back was starting to complain a little bit. Okay, but does that make sense? And so we wind up with like use cases and design models and test specifications and models, that relate to testing and different things. Thanks. Um, okay, and we'll talk about those different models, and we'll use UML as the mechanism for doing it. Not because UML is some eternal, and of eternal importance, and any more than Goff is of eternal importance, but UML is of historical importance for sure. Having some fluency with it is useful, but because most importantly, are you going to ever code and work in a development organization in which you are going to have to make UML diagrams that are by the book UML diagrams, the odds against it are quite high. Now, it doesn't mean it's not going to happen. It might still happen to you, okay? But the odds against it are pretty high. And the smaller the company, the lower the odds. But this is really important. If you have learned and studied how to build models using UML, later on when you're just, drawing circles on the board, right, as you do, draw some circles, draw some lines, circles, lines, boxes, right, you'll find that the way you draw circles and boxes and lines is affected by having processed about UML. Does that make sense? That's why I want you to struggle through, you know. Yeah, how do you make a perfect UML if the customer can't perfectly tell you what they want? Yeah, this is a perfect question. The customer doesn't know what they want. And this gets actually down to use cases is where that really comes in. Now, there are many, many times where the customer either doesn't know what they want, or if they do know, they can't, for whatever reason, as who said that? Was that Braden? Hang on. Yeah, it was Braden. That the customer can't tell you what they want. That is a process called requirements elicitation. And requirements, some people call it requirements gathering, and I don't like that at all. I think requirements gathering sounds like you're just out in the field, just picking clovers, Oh, there's some lovely requirements over here, you know. And no, it's I like elicitation because you have to elicit them. You're tease, you're like you're fishing and you're like, oh, it's difficult. It is difficult to determine requirements. So the ability to embody what you think those requirements are, especially in a way that's meaningful to the customer. So when you then show the customer prototypes, which is a model, pictures, diagrams, other descriptions, which are models, right? Uh, that's part of that process. So I think your intuition is right, Braden. It does kind of like converge on all of that, and it is a fundamentally intractable problem to really know what the requirements are. It is, and it's one of the areas where I think that I don't know, not deliberate, but in academia, we sort of do you a disservice. I understand, I think, why, but the disservice is we give you requirements nicely cooked. They're just perfect. They're disambiguated, right? They're differentiated. They're sitting on a professor's, website. There's nothing remotely like the software industry in that exercise. And if the requirements are ambiguous from the professor, you're pissing and moaning, talking to the dean or what, you know what I mean? You're gonna get upset. And at some level, depending upon some other dynamics, you might be fully justified in being upset. In a real world scenario where you're doing this for customers, nobody fully expects any of that to have been there in the first place. So if you are upset that nobody seems to know what it is exactly you're building, well, that's the struggle. That is the struggle. So, okay. So, yeah, they help us visualize. Can you make a UML diagram that represents an impossible design? It seems like a problem. So it depends, Braden, on what you mean by an impossible design. If you're vague enough, you can make a diagram that represents anything, as long as you're vague enough. The more precise you get in your diagram, the more it forces you to recognize the impossibilities. You know. Also, there's a QA process which should be going on constantly that, through which, um, you're looking at all these documents and specs and diagrams, and by looking at them, you're able to see through inspection that this doesn't actually make sense, or this would not actually work if we tried to, if we actually tried to build it. That those are some loose, Braden, those are some loose ideas, sort of, poking around that. Um, cool. Yeah. Oh, yep. Yeah, right. You can use English to articulate impossible concepts or logical fallacies or right. No, I think you're right, Sam. And I don't think that, and I don't know if you were saying that we were saying, but we weren't saying that that's a flaw in UML. I was never assuming that, but so I think it's a really good clarification to just articulate that it's not a flaw in UML. Um, and you know Now it is not possible to reflect. And again, Braden did not articulate what impossible design means, right? We didn't actually pin him to a definition of impossible design. But I think we can say with confidence that it's not possible to code with a software programming language, a program that is an impossible program. You know what I mean? And part of the reason is because it's it has to be disambiguated. If it's actually impossible, right, and you're forced to disambiguate things, if you can leave it ambiguous at key junctures, you can specify an impossible project. It kind of makes sense, doesn't it, Sam? Um, yeah, and I think Braden's on board as well. Contradictory or self-defeating, right? Not a flaw with UML. Absolutely. Okay, so yeah, continuing on, visualizing and understanding what we're building, documenting the design, and communicating it to others. That is huge. Again, the bigger the organization, the more necessary this is. Also understand that if you're going to talk about design, it's almost, in smaller companies especially, it's almost never just sitting in this happy repository with up-to-date documents about everything. It's a conglomeration of a document over here that was kind of half-baked, a number of shots that somebody took of a whiteboard after a big discussion, some some thing notes in a Jira repository, some notes during like a check-in of some code, right? An email thread, some threads on the relevant Slack channel. You know what I mean? Email stuff, text messages. It all converges to sort of embody the specification. And again, the smaller the company, the more varied it all gets. Okay. In fact, there was a legal case that I worked on a couple of years ago. Actually, yeah, it was 2 years ago right now. Actually, it was probably this week, 2 years ago this week, that I was in Chicago for this hearing. But there was a question about whether one of the questions at issue in this case was whether, sort of code had been misappropriated, you know. But of course, the truth was that the case really was about work product, and work product was defined in the contract, and the work product was much, much broader than source code. So the opposing side was taking a boneheaded and indefensible position. But they wanted to get the discussion just to source code because they thought that they could actually win there. It was really obvious when you looked at the case that that was the only place they could win, and that because all the other rest of the places didn't make any sense. But when I went in, and we went in with my team, and we were just kind of like, okay, I need email, we need all the emails, we need the JIRA reports, right? Um, Requests for changes, Git repositories, right, with check-in information, Slack channels, right, all those other things. And this was sort of a point of pride for me, but the opposing expert was really talented when it came to source code review. She was really good at code review. And I don't, I think she was a bona fide expert at that space and have no hesitation, to say, and would have said, in court, yeah, I absolutely consider her to be an expert in doing that kind of code review. But she was emphatic on us needing to get the discussion to the code and to stay in the code. And so in her report, she said something to the effect of questioning my, because I was basically, I want to see the emails, I want to see the Slack channels, you know what I mean? And she was like, Dr. Knudsen, you know, doesn't seem to be, he seems to be afraid to look at the source code. He seems more, you do get these ad hominem attacks sometimes, by the way, in expert reports where you're called out by the opposing expert, which is a very fun, you're just like some other poor professor somewhere is just calling you out. Anyway, and she said that Dr. Knudsen appears to be an expert at reading emails. And the best part about that is my partner and I, we got a real good kick. What's that? Right? Because the thing is that I was thinking was, well, I am an expert at software process. And when I come into a company and they, and they start talking about, well, company A thinks that company B misappropriated our software, right? And leveraged it into their code in order to, speed up their development process, right? Well, you understand that you can look in the code all day and maybe never find it, even if it really did happen, right? Because of a number of things you might do before you're checking stuff in. But inevitably, what happens is there's a lot of sloppiness. Anybody who's willing to steal code and try to use it to get a leg up on the competition is frankly not that smart, because it's almost always a failed venture just within your own company. Um, but there's almost always an email somewhere, which we did in this same case where I was an expert at reading emails. I was an expert at reading this one email where, let's just call the original company, company A, right? The one whose code was at issue. And there's an email thread from somebody in company B, and it's just like, hey, does somebody have that code from company A? you know, like, and it was supposed to have been like a reconstructed software thing, clean roomed so that there was no overlap, you know what I mean? And no tainted anything. And they didn't understand what clean room software development meant. Anyway, but literally there was an email that was just like, and someone's like, yeah, I loaded that over to the server. This is like well past the point where they were supposed to not have any taint, right? And they were going to try to clean room a brand new, fresh version that was not tainted, and which also, by the way, didn't even matter in terms of the case. It was just done. It was one of the worst opposing side defense arguments I've ever seen in a legal case. And I've done a lot of them over the years. But anyway, but the point I'm just getting at was that really it's this same idea that there's no like cohesive model where you go to find all the things. Oh, and by the way, another real smoking gun that we look at when we're looking at whether code's been moved from one area to the other is database schemas. You think about that, right? I'm going to have this one table. It's going to have these fields. I mean, it's a very unique blueprint. You can make a system, and once you start getting a database schema, it doesn't even have to get that complex, right? Just a few tables And the way you structure that, you know this, right? It gets very individual very quickly, like a chess game. There's stats about, after some number of moves, and it's not that many. I know it's less than 10. I can't remember. My son Brad would know. I'm going to go out on a limb and say it's something like 8 or 9 or 10. And if somebody wants to look that up, that would be fantastic. But essentially, it is there's a certain number of moves where statistically, it's pretty much you can show statistically that after so many moves, every game that goes past that number of moves is a unique game, just like every snowflake is a unique snowflake. Like it's not like everybody's out there just playing, the same 10 move game over and over and over again. It's like, any 10 move game is like the only one like that that's probably ever happened because the branching is so big. Well, same thing when you're doing a database schema, right? The branching is really, really big. The number of options, right? How if I even if you just give me, here's the data I care about, how you organize that into tables, it's going to have a fingerprint. You'll see the fingerprint in the database schema, not to mention tables with the same names, code that deals with those tables the same way, queries that expect the same kinds of joins, right, between tables. And you see what I'm trying to say, right? Um, so it's all these models. And then again, at the very loose sense, the model is included in Jira repositories and, you know, GitHub comments and emails and other stuff. And then models serving as a guide during system construction. That's another really good one. Okay, so here comes UML. I'm going to make it. My back says I'm going to make it. Um, so unified modeling language. Now, unified, what does that really mean? It sounds very powerful. And, we talked a little bit at the beginning about Goff and about the Goff book and the Hillside Group and, some of the pioneers in that field of patterns applied to software were a bunch of people who happen to have read, I've actually still got my copies here. They just happened to have read Christopher Alexander and discovered this over coffee or whatever. There's history, you can read about it, but that they just were like, whoa, wait, you've read, like someone's like, I just came across this amazing book, Christopher Alexander. And someone else is like, oh yeah, I know, I've read that. I've been thinking a lot about it. Somebody else is like, whoa, wait, I have too. And that's cool. But there had existed back in the day, back in the early 90s, there were a lot of different modeling tools, methodologies. Grady Booch had a method called the Booch method. There was Jacobson, there was Schler-Meller. They had the series of books called Modeling the World, like modeling the world in data, modeling the world. Schler-Meller's notation, in my view, was so bad that my advisor and I used to refer to it as modeling the world in ambiguity. It was really it was a very non-powerful sort of modeling language. There was who else showed up? Who else? There was a bunch. Rumbaugh, OMT by Rumbaugh. There was Ed Jordan had a method. Jordan structured analysis was kind of a thing. I mean, there were just a bunch and I did back in grad school a bunch of analysis of these different modeling, uh, what do you want to call it? These modeling languages, really. They were modeling methodologies, whatever. Well, at some point down the line, I don't think I put the names in here, but several of the bigger market share. So Booch was one of them. I want to say Jacobson. I can't remember. I want to say Rumbaugh was part of it, but there was a group of them that got together and they said, we would do better as consultants in our private practice as consultants if the market wasn't split. In other words, it's an old principle that I call, the name that I gave to it was don't compete on plumbing. Don't compete on plumbing. Okay. The original I kind of IBM clones. Before clones, there were companies trying to do like an IBM PC, but without using an IBM ROM BIOS until Compaq reverse engineered the IBM ROM BIOS into the Compaq ROM BIOS. And later on, there was a company called Phoenix that did a ROM BIOS. And these would enable computer manufacturers to build systems that were what they would sometimes call plug compatible, which means I could take certain software and put it on any computer and it would run. And you're like, well, duh. Well, yeah, but no, not back then. I did a bunch of work at Novell on different Japanese platforms, and like the vector tables were all different, and you had to like go figure out, where the vector tables were, how things worked was different. It was just not, standard. So anyway, uh, there was this idea and realization that look, don't compete on plumbing. It's not sexy and nobody cares. Standardize, then the field can grow around that standardization. If it's fragmented, the field can't grow. Has to consolidate somewhat. That makes sense? And essentially these folks in that fragmented world popped out of that and said, why don't we, in other words, UML was a marketing decision by the industry leading producers of product in the field and created so unified. What got unified? The market. How did it get unified? Because 3, 4 makers, manufacturers of tools and modeling languages and whatever, just said, yeah, we're going to get together and agree basically on how we're going to do this thing. We'll make it a name. We'll all kind of throw in, right? Same thing that happens with like Bluetooth, right? If everybody does Bluetooth and follows the Bluetooth spec, right? You now have Bluetooth interoperability. You don't have to worry about, oh, I've got my AirPods, but oh crap, I can't. And some of you are going to find examples where this is exactly a problem. Yes, it is a problem. But it's like, oh, I have to use Mitsubishi Bluetooth if I'm going to talk to a Mitsubishi Bluetooth device. But if I'm going to talk to, you know, Motorola Bluetooth device, I've got to have a different protocol stack or whatever. You know what I mean? It's just like all you're going to do is dampen the market. Better to unify behind a single idea and everybody piles on to do it the same way. So that's the rule of data communications. Okay, take something like Apache web server, right? Whatever, Linux. I mean, just go into any of these sort of common open source projects. They're really about standardize on the plumbing, get the plumbing right and get it standard and get it working and get everybody doing it the same way. Now the whole field is going to grow. That's what they were trying to do with themselves, of course, at the top of that heap. Um, and by the way, if anybody, I have a certain kind of cynicism when it comes to science. I am one. I am a science. I have a doctorate in science. Uh, but the idea that science is this mystical force that just moves, through the world, bestowing wisdom and grace, uh, it's not. It's the aggregate behavior of a bunch of individuals operating primarily out of self-interest. Not always, but predominantly out of self-interest. And it just happens to be that sometimes when somebody does something out of self-interest, it also happens to sort of like help humanity. Those are not mutually exclusive ideas, right? That doing things for self-interest. But I'm saying that in the case of Goff, absolutely, that was about self-interest. Um, UML, absolutely about self-interest. But the idea that scientists, and I don't care what your field is, but when just understand the motivations behind scientists, because they have a motivation. What is it? And it usually includes tenure, grant proposal, getting grant money and acquiring tenure. And so there's a selfish motivation is all I'm trying to say to science and the way in which science moves. Okay, so UML is important, and that, by the way, is another philosophical topic we can dig into. And I can recommend maybe someone can look this up, and I don't know that I've mentioned it before here. It's more of a 305G topic, but the CBC Radio, which was the Canadian broadcast company, did this thing that was called Ideas: How to Think About Science. And they did this about 15 years ago, and as a series of sort of, it's available now like as a mini series of podcasts, but they did it as a radio program. Fantastic, fantastic, and builds in some healthy skepticism about the motives of science. It's not like a hit piece or whatever, it was just an honest analysis of how to think about science. All right. Um, so here's why UML is important. Um, you do see it or things like it. That's important. And whenever you're looking at specs, papers, articles, books, you'll see it. And so it's another way of having a level of fluency. Okay. And usually we're going to look at diagrams that UML describes syntax for diagrams for structural modeling, behavioral modeling, physical modeling. So structural, which we'll talk about, things like class diagrams, the ways in which we're going to define things. And the physical is more about like how it actually runs. What does it look like as it's running? And those are two different things, right? And behavioral model deals with that. How do you look like when you're running, but also interacting with other people, with other objects, right? What are the interactions? And every category of UML diagram is another way to think about a system, just another way to shine the light through it. Okay. And then this is really, really important. I don't care if 5 years from now you remember precise syntax for UML. There's a good chance that a good number of you, oh, excuse me, that a good number of you will never encounter UML in your careers as official UML, that you will not encounter it. But if you've been through it, the ideas of the kinds of things, like if I teach you, oh, in this one notation, there's 10 key ideas, you understand that we're also teaching you 10 key design ideas. You see what I'm right where I'm at? UML, they already had to go through creating a method for documenting the cool stuff you can figure out. And having figured out the syntax for documenting it, the syntax itself is like a meta level spec to tell you that these are the kinds of things you should look at in your design. So having a reference to UML around when you're getting ready to go do design, and being able to go look at the UML and just say, wait, they've got these things called interaction diagrams. Oh, and you realize, yeah, we really ought to specify that, right? And whether you use, you know, canonical interaction diagrams or whatever, I don't care in the grand scheme of things. But having thought about it, it alters your thinking. Having thought about it at least one time. Okay. So you can actually look at all the notation in UML and look at it like it was a checklist of the things you might want to consider having in your design. Cool. And then I'm not going to break this down, but this is where we're going to go. We're going to talk about all these. And lest this just get super boring, I want to keep talking about design throughout this whole process. And there's just a lot of cool ideas we can talk about as we get into design. But what I want to be able to do is use these as ways of guiding class diagrams, objects, use case, collaboration. And weirdly, the one I'm going to probably beat the most on is use case, because I think it's probably the one that we do the worst and that is the hardest to do right and to sort of understand. Okay. I think now we have like 5 minutes, 4 minutes, and the back says, yes, we have 4 minutes. So I am in pain. I want you to know that, but I'm also filled with happiness and joy, um, because of being able to hang out with you. Uh, which one? I want to just hit a couple of things. Let me see if those are at the bottom. Okay, all right. Yeah, I just want to do a few minutes from a series of things that I call that are they're inspired by a book by Don Norman called The Design of Everyday Things. And I just want to hit a couple of these, okay? This, the way we're going to do Design of Everyday Things is I'll always try to save a little time where we can look at some of these things from a design perspective. They're like calisthenics, okay? This was the original, I don't know if it was the original, but this was the copy of the book that I had, by Don Norman, called The Design of Everyday Things. Uh, and I have my own, and so mostly what I use are my own experiences, right? And here's what Norman said. When you have trouble with things, whether it's figuring out whether to push or pull a door, the arbitrary vagaries of the modern computer and electronics industry, it's not your fault. Don't blame yourself. Blame the designer. It's the fault of the technology, or more precisely, of the design. Okay. And what I want to actually get to is, remember we did just a little bit, right? I showed you just a little bit. 2 minutes. Let's talk about this. What, why, what? I'm only isolating these 4 buttons. Talk to me. Text is fine, verbal's fine. What's that, Rick? Say more. Say more, sir. Yeah, right, right. I mean, isn't that the thing? Isn't that the thing? I mean, it's like, okay, I think that those are arrows that kind of want to go out. And then this one, right? Like it really wants to go out. And this one, yeah, yeah. Now, what else? What else? What other things are confusing? Take a look. Just study, look at the fish. Okay, look at the fish for a second. Right? The Braille. Yes. No, I don't read Braille natively. It's not, I mean, it's a little grid system of what? 6 dots? I think it's a grid system of 6 dots, 222. Somebody want to look at the, right, right. Yeah, the only documentation is Braille. What does it say though? Could have been, right? Could have been. But anybody, hang on a second. I want to do this real quick. Um, okay. Okay. It's really dumb. Okay, because I'm just gonna bring this guy over. I was trying to see, there we go. So yeah, I'm cheating in a sense. Well, I'm not cheating. I'm just getting, okay, so that one is O, and that guy is P, O, and then that's E, OPA. There's no N, OPE, OPE. There's no N. Well, OPE, but what is this? No, and I don't know if this is like appropriate, canonical spec if the Braille changed somewhere. But let's look at, so they are the same. Those guys are the same. Then here it goes. That's C, L, that's O. Is it OPN or is it, no, there's no N. N, not over there. Over here, right? It's a E. That's E. No, that's not even E. I'm a dumb. Hang on a second. I don't think it's chipped off. That's OP, and then that goes basically middle guy, some kind of middle guy, and then like middle, sorry, it should be like a left center and a lower right. Not on there. OP dot. Okay. And then what's the other one? Okay, hang on. I think I have one that might be a little better. And then we got to cut loose. Always we got to cut loose. Ooh, ouch, ouch. Uh, and I'm not taking the bait at all on that, right? I mean, we don't have time. Okay, let's go here. This one's got actually has punctuation. So I'm just trying to find one that has like the lower right. I'm trying to find that guy right there. And then this one is, well, that's the same one. Hang on. All right, we're gonna have to come back to this. But this one is definitely C. That's CLO. That's CLO. And then it goes two and then one up. Oh, it's S. Clos. 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 Close. Close. So that's CLOS, and that's OP plus mystery, right? I yeah, 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 and that's right. Characters, there's no more. Well, and the buttons themselves have shape that you can feel. So that might add context to the braille. You know what I mean? Does not look like they're raised. I think that's actually raised. But then we're still back to bar versus no bar, and then maybe there's sort of a, you know, classic braille thing for doors. What, you know, but even that, but as you're looking at it, you're just us, right? You know, basically there's two. I see two forced open and two forced closed, and I don't know what the difference is. And on that particular elevator, I tried every time I that was in some building where I was there regularly, and I tried every possible combination, and I couldn't figure out a differentiation between those two. Give that some thought. Could be front and rear. I don't know. You cheated appropriately. Alrighty. Well, we're out of time. We're out of time. But this is just again just to get you thinking. These are little tidbits. You know what I mean? I want you to be always thinking about design. I want to give you these so that you just get. Here's one other example. I had an MRI today to try to do follow on to figure out what in the crap is wrong. Why am I having this sciatic nerve pain and whatever? And over here where I live in Traverse Mountain, near the Five Guys, there is a restaurant called Spitz, SPITC, and I think it's supposed to be like a, you know, play on like you put meat on a spit, which is what you call that. But I see that logo, and all I can think of is that it's like a sunflower seed place. You know what I mean? I just think that I don't know. I just don't think that you should. I don't think you should name a restaurant after a function of expectorating. You know what I mean? I think that you are creating confusion in the minds of some, and that this is a problem. Anyway, hey, listen, I'm out, and I gotta go. Like I gotta go rest this back, like in a big way. So it's supposed to be like Mediterranean food, the spit stuff, Devin. So anyway, I'm beat. I have pain, right? Right back here. So anyway, it's good to converse. I hope that the stuff was still good, you know. Um, you know, hope that the content was meaningful and despite the playing through the pain, but you know, we're gonna get there. We'll get through this whole thing, and by the end of the semester, I'll be a hiking machine. That's my goal, is to be up and walking, hiking, and get a new lease on life. So anyway, thanks for all your good wishes, and I shall take care of myself to the extent possible. So that's it. I'm out. I'm gonna just jet and go. Ping me if you need to get a hold of me. You know, just ping me and we can see when I'm up to it. The weekend will be a little better, I hope, because I'm feeling definitely hammered right now. So, all righty, my friends. Later. Yep. Oh, I think that I was just suggesting, uh, I don't know, right? I was thinking make sure you've logged in recently. Maybe somebody else can do kind of a jump on. If you could solicit somebody else's help to try to debug it with you, you know what I mean? And maybe somebody be willing to jump on and say, let me try it over on mine and, see if just having an extra pair of eyes can help. You know what I mean? Because I don't have an answer, right, Tobias? I got no actual answer. So, yeah. All right, man.